Hello. I'll wait a few minutes for people to show up. While we're waiting, hey Radislav, I have a couple of questions about your open pull request. There's the to make the dout paths faster one. Can you tell us what the current status is there?
Sorry, which one, please?
It's 20290. It's the dout one.
1 second.
Here, I'll put it in the chat.
Thanks. This one. Yep, sure. I want to clean up some things, especially handling of the -1 level. And after that, I think it will be ready.
Okay, cool. And just a comment on your other one, the MD config cacher. I think the cacher itself looks totally fine. I think it's just the second patch that uses it with static declarations. That should change.
Yep. I fully agree with you that static. I fully think the case, and I fully agree that static isn't a way to go. Unfortunately, because it would bring the minimum and the minimum size of boilerplate. Still, putting as a member would be acceptable. However, we could face another issue with that. We have atomic inside, which means by default it's non-movable. So it could be a problem with inserting vector. So I guess
I think it's okay because these are going to generally live in singleton long running classes, like the OSD class or the PG class, that they don't have to be moved or anything like that. So. Yeah.
Okay. I will make the changes and update the pull request.
Okay. Cool. Thanks. Let's see. The only other interesting pull requests recently, there's marks that changes the O streams when not debugging. I didn't look at this closely. Kifu had a nit about structuring something with return value, but this is like shaves off 5% of the CPU time for one, or wall clock time for one of these threads. So probably worth. Have you looked at this one, Josh?
Yeah, it was just a stupid thing where we were outputting information all the time instead of only when like debugging was turned on. So yeah, definitely want to fix that.
Okay. All right, the AIO context final thing looks fine. I'd mark that needs QA. Let's see, there's the indirection layers for sharded opwork queue. I think that the tiny vector stuff all looks fine. The bit I'm worried about is this is changing the sharded opwork queue, and it's getting it's getting totally ripped up in my refactor branch for peering. So I think we should wait on that. Maybe just merge tiny vector, and I can either roll that change into my pull request, or we can wait until after.
Sure, I will split the pull request.
Tiny vector bit. Okay. Does tiny vector have unit tests for it?
Not yet.
No. Maybe you just make a couple just to make sure nothing stupid. Should be reasonable. Okay. Let's see what else is there. There's a there's this EC backend using the local read path stuff. Okay, that's waiting on me. I need to fix that. I just need to re-review. What else? I talked to somebody at Intel, I'm forgetting who. They said they're still working in the QAT support for compression, so that's good. But it's still in progress. Let's see, there's one here about delaying PG stats calculations until we're flushing. That looks interesting. Looks like Kifu did some testing and ambiguous whether it passed. It's a little bit delicate. Should probably come back to that one. That's, I don't know, I think that's the main things. The pull request that changes the collection handle stuff merged, that should be a no op as far as performance goes, but I'm working on the one that rips out all the unreadable stuff and compensates in file store. It's eliminating a bunch of callbacks, so we'll see. I'm hopeful that it's going to be noticeable speed up on Bootstore, but we'll see. I'll have to do some testing. I'm running it. Yeah, I'm cleaning up the branch and testing it. So once it's working, then maybe we'll do a last batch of tests on file store and on Bootstore to see what the delta is. That's all I have. Anything on the agenda? No, there's not even a thing on there. Anything anybody wants to talk about?
Actually, I have a question regarding this mdconfig cacher.
Sure.
As far as I understand the code, it adds observer for every variable cached. Is that right?
Anytime you instantiate it, yeah. Yep.
Yeah, it won't cause any problem later when we are going to move full on with this approach?
It causes, but in rare situations, I assume that that updates to the that injecting args or something like that is extremely rarely. It's just a trade-off.
And it's more expensive. Yeah. Yeah. And I think we can also make it better too. Like right now, the observer is when there's an update, you basically call every observer. But I think we could, in there, we can make a map of like, if you're observing these specific keys, like make a list per key of the observers that you care about, and so that you only call the observers that matter. That sort of thing.
By the way, the API is already there. Defining observer requires you to provide a list of keys you are interested in. So just matter of implementation.
Yeah, I've seen this in OSD code, for example, and it's simply observing a number of keys and attaches a single observer for all of those keys. So I think that's, in my opinion, a better approach.
Yeah, I mean, it's better given that right now the config calls every observer when there's any update. But if we only called the observers affecting a key, then it would be better the new way, because then we wouldn't call that big function and test whether every possible key is in the change set and then call them or whatever. It would be better in that sense. So, but again, this only matters when you're like setting a config value at runtime. So like nobody really cares how much CPU overhead I think it takes.
All right. So
does that make sense?
Maybe not sort of. To be honest, we are doing sometimes a lot of config changes in production on the runtime. So I'm not sure if it is going to affect production runs in noticeable way. Hopefully not. But
Yeah.
I think before it will happen, it requires better parts of configuration to go into this caching approach. And
I would
I think yeah.
Sorry. If that's the case, I would just take a look at the config code that calls the observers and update that, because I think we can make it only call the observers that are affected for the changed keys, and that will eliminate the concern. I think right now the implementation is just the naive sloppy thing, and that's why.
In the meantime, I have been observing how the get file works actually in under profiler and so on and so on, and I came to conclusion that get val is slow not only because of the traversal over the STD map, but also because of the normalizing keys, even if they are already normalized. So I've made a short PR to fix that, and in my testing, it improved things significantly. At least for the keys that are already normalized, which is the case of most common case in the Ceph code.
Yeah. Normalized key name. Oh, I see. Yeah. So the internal calls, right? That makes sense. That normalization thing should only really be necessary for like when you're parsing the config option, where it might be dashes or config file or something like that. Yeah. But all the internal code can be precise. So
guys, it could make a small change to the API, because there is assumption that caller of getVol can use no backslash or something like that, but we could try to detect such situation in runtime, having a build with checker could help. Some kind of optional checking. Some kind of
if there's like a static assert, I think I would actually lean toward making the callers that have unsanitized config option names and make them explicitly call the normalize function. And then get val doesn't have to normalize, right? It's assumed that it's always getting a pristine, well-formed thing, and it asserts it.
Yeah, that would work too.
Yeah, it's a little bit more work because we have to like look at the callers and decide whether it's a pristine source or not. But I think it should be pretty straightforward, because it's either passing in an actual static string, C string or whatever, or it's passing in a variable, right? And I think it's just parsing config options that are messy. When you have like a config set command that's coming from over the wire or something like that, or inject args, and parsing config files. I think those are the only times when you get sort of these messy strings. So I'd lean towards doing that. Okay. Does that sound reasonable?
Yeah.
Okay. All right. What else? Anything else we should discuss?
Just quick question about the reactor of C-star, or anything we want to replace it with. Does it try to grab calls, tasks into basing on the same code? I mean, here some kind of
grouping them
batching
together.
concept.
Yeah, it has a concept of execution batches, so that you can preserve cache locality and run the same exact code.
Ah, cool. It will be really,
at
really
once.
cool because I observed that on the read path, they're like just a decode pipeline of nowadays x86 CPUs is involved in more for more about 55% of delivered micro ops, which means something terribly bad. We are not using the decoded micro op cache at almost at all. And I'm not surprised because the read path is in OSD and Bluestar is basically long sequential code, so it has no chance to fit inside the micro op decoded micro op cache. It's too small simply. Dividing it into stages, making some pipeline or something like that could improve situation a lot. Because
yeah, that's a good point.
On the reads, we are also starved because of frontend of CPU's frontend. It's not able to deliver micro ops to backend. So still a lot of waiting on data on memory after the micro ops gets
Sure.
to execution.
But yeah, that's an excellent point. That's exactly the type of thing we'll have to start thinking about. Keeping tasks very small so that they do fit in the micro op cache. And when possible, grouping them together.
Yep. Even for the cost of latency, I think.
You think this would improve throughput more than latency?
Sorry, could you please repeat?
Oh, you mean in terms of the grouping to improve throughput at the cost of a little bit of latency for the other ops?
It should definitely improve throughput.
Do you have some kind of data to prove this?
I'm working on a report from profiling. I will share it next week.
Okay.
Also, I considered, because I can see a lot of eCache misses and also ITLB misses. I think about pipelining the read path. I know it's very, very controversial because each stage adds some latency, some additional work because of passing data to next stage, etc., etc. However, at the moment we are running with so low IPC, around 0.4 or lower, that if we could improve it, maybe we could also squeeze some latency there.
Are there any knobs in the reactor that let you sort of control that, Josh?
So for the task grouping bits, it's more of an explicit way that you can chain together pieces that represent a part of a task or a part of a group of tasks, where you would schedule them. And I'm not sure exactly how much configuration it has at the moment in terms of how many it waits for before running them, or that is how it does the batching.
Okay.
That's probably something we'll want to look at more, though.
Yeah. Okay. Okay. And I think the other thing we can do is reduce the complexity of some of this code also.
Yeah.
I think it's going to be part of what happens as we wrangle this. So there's less going on.
Yeah, moving more of the checks early in the pipeline instead of later, so that there's less code there.
Mm-hmm.
However, I'm not sure whether we will be able to make that without splitting all the read path into stages, even a pretty large number of stages, we'll be able to get benefit from micro op cache. It's small. It's around 1.5 thousands of micro ops. So
yeah,
it's very small part of instruction cache, basically around 6% or something like that of total instruction cache size. So I'm pretty sure. I guess that a lot of instruction cache and ITLB eviction events come from jumping to kernel each time we see read. At the moment, there is no batching, absolutely no batching. We are using most of the time p-read, one p-read to per read operation. I'm trying to put some kind of additional stage solely dedicate on top of the async read stuff, trying to compose incoming reads, incoming IO context into a graph that could be put into kernel using one small IO submit call. However, it will be done in a separated threads. So having a C-star in place would be very, very useful here, I think, because it has dedicated threads for interaction with kernel. Am I correct?
Yeah, that's right. I think it'll be interesting to see once we've converted more the OSD more to C-star, that once when you can start measuring these things more exactly. In that case, I think that at that point it'll be more interesting to look at these kinds of micro optimizations. It's really unclear to me, like FEB measuring right now, if it's going to have the same kind of bottlenecks that we will later.
If we are talking about micro optimizations, maybe there is some low-hanging fruits. The profiling shows we have a lot of micro operations delivered by the microsequencer instead of normal decoders, which means that the throughput, that the front-end throughput is very, very limited. Trying to find source of them, it could be that the divisions we have in the pipeline, we have on the read path, are responsible because of that. However, there is no mention about there is no direct mention that division goes through microsequencer on x86 on Skylake, for instance. So it's very unusual to see microsequencer activity in this part, in such code.
Would this happen to be using the erasure coding pools or something?
No, definitely nothing something like that. Just a plain replicated pool. I thought it could be related to CRC activity, but that's not the case.
Yeah, I'm not sure where exactly it would be coming from.
I tried to use some front-end events for recording, for annotating. So I shouldn't, to be honest, because first of all, they are not precise. Second one, they are far away from the retirement stage. So the results are very, very rough. Still, I can observe very, very interesting correlation between microsequencer activity and divisions. Angus Fogg's manual says that each division, that divisions require around 10 micro operations. When I can find some sources claiming that each in x86 operation that takes more than 4 micro IOPS needs to go through sequencer. And we do have some divisions across the read path. I'm eradicating them right now. Hopefully we'll have a pull request today or tomorrow and repeat the profiling session.
Okay, cool. Just doing a quick search. Most of them that I see are in the cache tiering code, which wouldn't be involved here. Right. Anything else anybody wanted to discuss?
I don't have anything.
All right. Well, thanks everybody. I guess we'll have a short meeting this week then, and see you maybe next week. Maybe not because there's a conference going on, but
Yep, we'll see.
Yep.
I can't remember when is Mark back next week? Or is he out another week? I can't remember.
I can't remember.
Yeah, we'll see. Anyway. Yeah. All right. Thanks, everyone.
Thank you.
Thanks.
See you later. Bye.